guys, it's Miss Marfleck here. We're finally done with that Algebra 2 review, and now we're moving on to our Introduction to Calculus, and that's going to be working with limits. Limits is pretty much going to take us towards all the way through to the end of the year, and we're going to start off with limits graphically. Now, there are a few different representations for our limits, primarily graphically, numerically, which is tables, and then the hardest one, which is algebraically, just working with the equations. We start off with graphically, that way you maybe have this visual for how limits work, and then it will be helpful when we see the equations kind of later on in future videos. Make sure you stick around for this entire video because like I said, we really are laying the foundation here for our calculus, and this is a really important topic. Now, this topic I think is best done with practice problems. So I did write out all of our notes for today, and I'm going to upload the notes so that you don't have to really focus on writing here because there's going to be a lot of definitions to get us started. You'll have the notes on your computer, and then you can really just focus on understanding limits and then our many practice problems, which we're going to get to. So you may have heard the word limit before, definitely in Mean Girls or in maybe a movie or somewhere else, but you maybe not know what it is. And I'd like to start off with speaking generally that limits are really helpful because they're a way to analyze a function. And I like to think of this function as a continuous motion. So if we want to analyze a continuous motion, it's kind of helpful to think about the continuous motion as this infinite sequence of kind of standstill snapshots. And we're able to pull one of these standstill snapshots really close to maybe a point that we want to analyze, and that gives us some information about the function. I also like to use the analogy of, watching a football game. I'm not a big sports person, but let's say you're watching a football game and you see your team is about to score a touchdown, and, they're at the 30-yard line, then the 20, and then the 15, and then the 10, and then the 9, the 8, the 7, the 6, and we're getting really closer to a touchdown, and then all of a sudden, your TV buffers or YouTube buffers or whatever, and you can't see where the ball is, but then the TV comes on a second later and you see that your team made a touchdown. So what limits allows us to do is analyze functions that aren't defined, or maybe are undefined at a point, and it's really helpful because maybe we don't have the TV screen for what happened with the ball at the 5-yard line, but we know if it was at the 10 and then a second later it was at a touchdown, we know at some point it crossed that 5-yard line. So what we do is we approach this function from one side, from the other side, and then we're able to kind of analyze and make conclusions about how the function is reacting. And then I wrote that here, what we're doing is we're analyzing what happens to the function, which is going to be our y value as we approach a certain x value. We're going to start off with our notation because like anything else, you can't do practice problems unless you know what notation to write it in. And our limit notation, we have this little definition here. And we're going to let f be a function that's defined on an open interval, and the interval is containing this number a. Now, just like I said earlier, your function may not be defined at a, but we can still take the limit. And what we're going to do is we're going to read, this is our notation here, we have limit, and then kind of small underneath, we have x and then an arrow to a. Of f of x, this is going to be a function. This could be square root, it could be a quadratic, linear, absolute value, rational. Okay, so this is some function, and that's going to be equal to some number. And then we read this statement, the limit as x approaches a of f of x is equal to L. So we can say, the limit as x approaches 2 of square root of x is equal to a number like 1.14 or something like that. Okay, so we're using this idea of approaches, so we're not exactly maybe equal to a, maybe we don't have what happened at the 5-yard line, maybe we'll just analyze when we have the footage from the 6-yard line and the 4-yard line. Okay, so we're approaching some number a. And then that's how we're going to write all of our problems. Limit, lowercase, x to arrow to a, the function algebraically is equal to some number. All right, and then now we're going to take a look at our one-sided limits. We're first going to start off with our left-hand limit. Now we can tell we have a left-hand limit when you have a little minus sign next to this number. That means analyze the function as we approach this number on the x-axis from the left. So when you see a minus, you're analyzing the function from the left side. You're coming towards that x value from the left, and you're seeing what it's equal to. And then you guessed it, with our one-sided limits, we have our left-hand limit, and then we have our right-hand limit. And our right-hand limit, you could tell, is right-handed by this little plus sign here. So that means analyze the function as we come from the right-hand side to see what that y value is equal to of that function. So what we could do is you can have functions, you have limits like this, which we're going to see as a two-sided, or you could just analyze from the left and from the right. So it's really important before you even start thinking about the problem to kind of check in and see, do I have that minus sign or do I have that plus sign next to our number? Now keep in mind the minus and the plus side is on the right-hand side, because sometimes you'll have a negative, let's say you have -3, it'll be like a little exponent, a little negative sign on top to denote our left-hand limit. All right, and then now with our one-sided limit, we're going to use our one-sided limits to help with finding our two-sided limits. So a two-sided limit does not have a minus or plus sign next to it. It's just x approaches a. Now when you don't see a minus or a plus sign, it's assuming that you're doing both. You're approaching from the left and you're approaching from the right. And then we're going to see that this two-sided limit is equal to that number if and only if when you approach from the left, you get that number, and when you approach from the right, you get that number. So if you're approaching from the left and you get 3, and you're approaching from the right and you get 3, then that two-sided limit is equal to 3, because they're both equal from the left and right. And then we have a case where our limit does not exist. And that happens, our two-sided limit does not exist when we approach from the left and we get one number like 2, and then we approach from the right and we get another number like 5. And 2 and 5 are not equal, so you're approaching the function from the left, from the right, we're getting two different numbers. The limit does not exist at that x value. And then we abbreviate does not exist as D and E. And then I really didn't know where to fit this, so that's it for two-sided limits. I really didn't know where to fit this next part in our notes, so I just wrote disclaimer, okay, kind of warning here. You could have a limit, like a two-sided limit that approaches A, and it exists, and it's a number, like 4 or 5. But then when you evaluate the function at that number, it is not the same answer. So sometimes these two are not equal. Now, you may think they are equal. Intuitively, I feel like they should be equal, but when we analyze like a picture like this one, well, as I approach A from the left, I get L. As I approach A from the right, I get L. So my two-sided limit, my approach from the left and right is L, my limit is equal to that number. But when I go to evaluate at that X value, I actually get this other defined circle up here. So that's kind of just a quick disclaimer, just a warning that those don't always have to be equal to each other. And we're going to see that when we dive into some examples. All right, the examples is really, I think, the important part here because this can mean there's a lot of words here, and it's helpful when we have the pictures. So just once again, we went over our notation. As x approaches a of a function is equal to L, we can approach the function from the left-hand side. We can approach it from the right-hand side. If you approach from the left and the right-hand side and they're equal, you get that number. If you approach from the left and the right-hand side and they're not equal, it does not exist. And then our limit does not always have to be equal to what our function is at that point. All right, we're going to move on to some example problems here. And these example problems are amazing because the function is like this really weird, choppy piecewise function. All right, we're going to take our time here, and we're going to start off with number 1. All right, I'm going to use my little kind of pen here because it's a little thinner to analyze the function without writing. And we're going to start off here with number 1. All right. We're looking to find, this is f of x, okay? This whole piecewise function is f of x. And I'm trying to see, okay, what is the limit as x approaches -5? From the left, that little minus sign. So I need to go to -5, and I need to approach it from the left, and I need to see what is my y value equal to. All right, here's -5, but I'm not coming from the right, I'm coming from the left. So as I come from the left, here's the function, right? If I come from the left towards -5, my values they approach the y value 2. All right, you can see here, we're at 4, we're at 3.5, 3, 2.7, 2.6, 2.5, 2.1, and as we approach -5 from the left, our y values are getting closer and closer to 2. So there's our answer. That's a one-sided limit. I just looked from the left. All right, now this next one here, I approach -5 from the right. Plus size means coming from the right. This is where things can get a little confusing. Some people think towards right, so they come from the left. No, approaching from the right, so you're actually like moving your pencil left. So here we are, limit as x approaches -5 from the right. So I'm approaching -5 from the right. Here's the right. I'm coming from the right. Oh, here's the function. And as I'm getting closer and closer to -5 from the right, my y values get closer and closer to 2. So our limit as we approach -5 from the right is 2. And then now I don't see a plus or minus. So this is a two-sided limit. As x approaches -5, I need to know from the left and from the right. So I see, is my value from the left and right the same? If it is, then my limit is that number. If it is not the same, then it does not exist. Now, sometimes you'll be given a question like this as x approaches -5 without doing the first two. So then you have to go to -5 and say, okay, when I approach from the left, it's 2. When I approach from the right, it's 2. Those two are equal. My answer is 2. And then here's that disclaimer from earlier. When I go to actually evaluate f of -5, that means give me the y value when the x value is -5. Okay, my y value when my x is exactly equal to -5 is 1. All right, so keep in mind these approach the value 2, but they're not equal to 2. It does not have to be defined at -5. But here, when I plug in -5 for x, my y value is 1. And there's that disclaimer that these two may not be equal sometimes. All right, moving on to number 5 here. We're going to approach -2 from the left. All right, so I'm going to my -2, and I'm coming from the left. So here's my part from the left, and as I get closer and closer to -2 from the left, my y value is -1. All right, and then now I'm going to approach -2 from the right. So here's -2, and I'm coming from here. I'm trying to figure out where my function is. Okay, here's the function. I'll pick it up. Coming from the right towards -2, and my y value approaches 4. So as I approach -2 from the left, I get -1, but when I approach it from the right-hand side, I get 4. These two are not equal. L does not equal M. This two-sided limit, where I don't see a minus or plus, does not exist. The limit does not exist because they don't approach the same value from the left and right-hand side. And then now I'm going to evaluate f of -2. So at -2, what's my y value? This is not defined. That's not defined. It's this y value here, which is 2. And then there's a perfect example where you could have just completely different answers from when you're approaching from the left, the right, the two-sided limit, and then what the function is actually defined at. All right, moving on to number 9 here. We're going to approach 0 from the left. So here I'm at 0. I need to see where my function is from the left. Here it is. So I'm coming from the left towards the x value 0. My y value gets closer and closer and approaches the L value 6. And then now I'm going to approach 0 from the right-hand side. Okay, I'm coming from the right, getting closer and closer to 0 from the right, and my y value is 6. And then now I have my two-sided limit, okay? And it exists and is a number if my left and right-hand side are equal to each other. And as I approach 0 from the left, I get 6. As I approach it from the right, I get 6. So the limit, two-sided limit, as I approach 0 from left and right is equal to 6. And then now I'm going to evaluate f at 0. So I got to see what is my defined y value when my x value is 0, and that is also equal to 6. All right, we're going to keep it going here with 13. We're going to approach +1 from the left-hand side, okay? So here I'm at 1. I'm going to approach from the left, and as I get closer and closer to the x value 1, my y value approaches 7. And then now we're going to approach 1 from the right-hand side, I'm going to get closer and closer to 1 from the right. Okay, here's my right-hand side. Closer and closer to 1, and I approach the y value 4. And then I can see my left and my right-handed limit are not equal, so my two-sided limit does not exist. And then when I go to evaluate f at 1, I see what's my defined point. F of 1 is 7. All right, now we're going to try something a little different. I'm going to put the paper kind of over part of the function to maybe help us visualize a little better as we approach from the left and right. Okay, here we are. We're going to approach positive 3 from the left. Okay, so I'm approaching positive 3. So I'm only looking at 3 from the left side. Okay, and as I approach 3 from the left side, my y value is 2. And then now I'm going to approach 3 from the right side. That's what that little plus there means. So I'm coming and I'm approaching 3 from the right, and I see my y value is also 2. And then now my two-sided limit, I have to account for both the left and the right. If they're equal, then my answer is that number. If not, our limit does not exist. And then now I'm going to actually evaluate f of 3, and we're going to see when x is 3, what's our y? And when I look all the way up and down x is 3, I don't have any defined y value. So f of 3 does not exist. And here's another example to that disclaimer earlier, that these two don't have to be the same, even though intuitively we may think they are. All right, here we are. We're going to approach 4 from the left. Okay, I'm going to approach 4. Coming from the left, as I approach 4, my y value approaches 1. But then when I go and I approach 4 from the right, my y value approaches down here, which is negative 4. And then now my two-sided limit, as I approach from the left and the right, okay, two-sided limit, you don't see any minus or plus. They are not equal, so the limit does not exist. And then now we evaluate f at 4. My y value when x is 4 is here at 1. All right, only one more set to go here. And we're going to approach 5 from the left. Okay, here's 5. Approaching from the left is this function, because it's on the left side of 5. And I approach the y value, negative 3. And then as I approach 5 from the right-hand side, my y value gets closer and closer to the y value, 1. And then you could see here in this last one that when we approach from the left and the right, they are not equal. Negative 3 does not equal 1, so our limit does not exist. And then lastly, f at 5, my y value when x is 5 is equal to 1. All right, so like I said, this is better done with many examples. So we spent more time on the examples than the actual notes. Make sure if you're struggling, kind of start this video all over again and maybe kind of go back and forth for each problem looking at the notes. Okay, well, this is left, this is right, and then two-sided is both left and right. Now we're going to just take a look at one more thing, and that's going to be our limits graphically when we're approaching infinity or negative infinity. And it is actually going to be the same thing. When you see the little plus sign or the minus sign, that means that you're doing the one-sided limit. When you don't see any plus or minus sign, that means that you're doing a two-sided limit. And then we're going to get started here on this example, classwork 2. All right, here I am. I want to approach 2 from the right. I know the writing is really tiny, so I'll read it aloud. X approaches 2 from the right. All right, so here I am at 2. I'm coming from the right-hand side, and as I approach from the right-hand side, my y value is equal to, what's that? 3. And then we're going to approach 2 from the left, and as I approach my x value 2 from the left, my y value is equal to 5. And then as I just approach 2 from the left and the right-hand side, they are not equal. My limit does not exist. All right, now this one might be tough to read, okay, but I'll read it. This is x approaches negative 2. Now, I don't see any plus or minus up here, so this is a two-sided limit, which means I need to check from both the left and the right. So I'm going to first check, okay, as I approach negative 2 from the left, I get 5. When I approach negative 2 from the right, I get 5. So my left and right-sided limits are equal. So when I approach -2 from both sides, they're both approaching 5. So that limit does exist. All right, we're going to approach 4 from the right. Here I am at my x value 4, and I'm coming from the right, and my y value is 6. And then here's my x value 4. I'm going to approach from the left, and my y value is also 6. So when I approach 4 from the left and right, they're equal. It's equal to that number, 6. And then we can evaluate the function f at 4, and I can see what is my defined point at f at 4, and there is none. So this one does not exist. All right, and then here's the 2 examples I really wanted to get to, and this is going to wrap up our lesson. We're going to see in our next video when I do a brief review, we're going to do some more with infinity, but I just want to finish off as x approaches infinity. So as these x values get bigger, 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 and bigger as we go from 0 to 6 all the way to 1,000, 1,000, so on, you could see this function keeps going up, up, up. We have to assume it keeps going up because of the arrow. Up, 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 up. So as we approach infinity on the x-axis, our y values approach positive infinity. And then here, as our x values approach negative infinity, so as these get smaller, our y values also approach negative infinity. And then that wraps it up for today. We are going to take a look at some more examples the next time we meet, but this is pretty much it for limits graphically. So if this was extremely confusing for you, please start the video over again, review the notes on limits graphically, one-sided limits, and the two-sided limits. Email me if you have any questions at all, and get to work on your homework, and then make sure you're checking your homework with the posted answer key if it's not on Quizzes or if it's not on Google Form. I haven't made it yet, but make sure that you're checking whatever answer key you're getting, just to make sure you're getting these values right, because it's really important that we understand this kind of fully, because the tables and the algebra is going to be a lot more difficult. Okay, email me if you have any questions. Get to work.